Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will model this part. As you can see that I have already modeled it, and it is matching with a isometric view of our reference drawing. So we will read all the dimensions of this orthographic view, front, top, side and sections, and we will model this part from the scratch. So for this tutorial I am using FreeCAD version 1.0, so you must have at least 1.0 or higher version of FreeCAD. Now I will close this file and create a new file. You can also visit my website macnexus.com, where I write articles and tutorials on FreeCAD, and you can also access my 3D part library of FreeCAD. You can download the part from here and you can use in your projects with modifications. You can also access my 2D drawing library, where you can download these 2D drawings and you can create 3D models with respect to these drawings. You can also support me on ko-fi.com. You can buy me a cup of coffee. Your small support will help this channel to grow, and it will motivate me to create more awesome content on FreeCAD. You can find my Ko-fi donation page link in a video description, as well as you can also see my Ko-fi page URL on this header. So let's come back to our tutorial. Now here I have created a new file and part design workbench is active, and now I will create the body and I will on my origin plane. And now we will read our model and we will create our first sketch. So if we see our isometric view, so we will first create this profile on a front plane, whose detail we can get here. Now let's select a front plane and click on the sketch, and now go to the model tab and hide the origin plane. Now here first we will create a circle, and I will make this circle as a construction circle and give the dimension of 72, because the radius is 36, so I am creating a diameter. And now this is our origin which we have created here, and now we will create one construction circle at approximate location here for this. So click on the circle and also make this circle as a construction one. And now let's give the dimension. So we can see here the 29 dimension from the origin, so select a smart dimension and provide the 29. And now from this axis to this center is of 12 mm, which we can see here. And now let's move the dimensions. So this is the construction geometry, and let's also fix this diameter, which is a construction one, so we can give the roughly 19 mm. And now let's create a 3-point arc and then create 2 lines, and then we will create this arc. So here go select a 3-point arc, select this point, and here make the center coincidence. And now we will create an approximate 3-point arc, and whose center will be coincidence to this construction one, and add a coincidence. and this radius is of R14, so we will select radial constraint and provide it R14, and now we will join these 2 points with a line. So select a line tool and join it, select the line tool and join this, and now we will move this line and we will also move this line and move this arc. So first let's add a tangency between this arc and line, and same way add a tangency here, say tangent, say here, say tangent, and now we can see that our sketch is fully constrained, so we will come out of the sketch. Now we will create a pad of 34 mm. Select the sketch, click on the pad and give the 34 mm and say OK. Now let's move to the next feature. So if we see the front view, so we have created this face, and now on this face we will create this slotted like cut. So let's select the face and click on the sketch and click on the project geometry and project this radius, and now we will select a slot tool, select this point and this point, and now we will make this arc and this arc as equal, which we can see in the image. Now our slot is fully constrained, and now we will create a pad of 21 mm. So select the sketch, click on the pad and say 21 mm and say OK. And now let's switch to the isometric view, and now here we will create this profile. So press 0 and here we will refer this front view. So we will select this face and create a sketch, and now click on the project geometry and project this arc and also project this radius, and now here we will create one rectangle and we will delete this line, and this is of 8.6 mm, so we will select a smart dimension and provide it 8.6, and now we will provide the distance 64 mm, and now we can add a vertical relation here between these 2 points, and now we will create 3-point arc here. Select and create a 3-point arc and make this and this as equal, and now let's fix this point with the origin and give the horizontal dimension of 122. You can check this dimension by adding this, and now I will select a 3-point arc and select this point and create a 3-point arc, and now here I will select this line and arc and add a tangent, select this line and arc and add a tangent, and now here we will see what is unconstrained. So this is the unconstrained because we have not fixed this line. So from the center we will give the dimension of 38. Select smart dimension, select it, and give the 38. And now let's see what it done constraint. So here, if you see here, tangency is added, so we will make this coincidence. Now this will be in a equal proportion. And now if you see here, here is a 12 mm is given, and this is the tangent with this line. So here I will select this and this and add a tangency. So you can see that it is a perfectly tangent, and if we join this line, we can get the tangency. Now let's close the sketch, and we will create an extrusion. Now here we will learn how we can offset the extrude in 2 dimensions. If you see here, so here is a step of a 2 mm. So we will click on the pad, and from here we will select 2 dimensions, and first dimension we will give the 48, and we will set it reverse. So first let's make just a dimensions and say reverse. So now you can see that in one direction it is created. Now add 2 dimensions, and here I want a 2 mm offset. So here I will provide -2. So here if you see, our sketch is on this face. If you go this pad, and if you see, this is the -2 distance which we have given in 2 directions. So this is how we can create extrusion offset to the sketch. Now we will off it, and let's move to the front view. So here we have to add the material here. So we will select the face and click on the sketch, and we will project this horizontal and vertical. Click on the project geometry, and select a rectangle tool, and add a rectangle. And now the thickness is of 3.4. You will minus this 8.6 from tile, you will get it. And now horizontal distance is of 64. And now here we can do one more thing. As in our previous sketch, we have given this distance 64. So instead of giving dimensions, I can add a coincidence constraint. So that once this 64 distance of a pad change, then it will automatically get updated. Now close it, and we will add the material, and we will define this end face. So select the sketch and click on the pad, say reverse. From here select up to face, and select this face. Now say OK, say 0 for isometric. And now we will create our next feature. So let's move to the isometric view. Now we will create this feature, and for this we will create the sketch on this face. So let's create a sketch, select this face, and click on the sketch. And now let's rotate our model, and let's project this geometry, required geometry. So click on the project geometry, project this edge, this arc, and this edge. Now let's switch to the front view, and from here we will switch to the wireframe. And now we will create our profile. Select line tool, select this and this, and let's select a 3-point arc. Select this and this, and set it equal. And now we will select a line tool, and now let's also project this radius. So click on the project geometry and move to the front plane, and here we will create arc. So basically we are trying to create this profile. So let's select a 3-point arc and select this and this, and let's add a tangency, set to the front view. And now let's create 3-point arc here, and now let's select this and say tangent. And now we will make this point coincidence on this axis. Now let's create a 3-point arc of R22. So we will select a 3-point arc, select this and this, and let's add a tangency. And now move this arc and create a horizontal line, and project this edge. Select a line tool, create a vertical line, and also make this vertical, and this is of 6 mm from the edge. So we will select it and give the 6 mm, and this is the height is of 16 mm. So we will provide the height of 16 mm. Now move this 6 mm and 16 mm, and now let's add a tangency here. So till here our sketch is fully constrained. Now we will again project this geometry and select a 3-point arc, select this point, and here let's select this and add a tangency. And now create one more arc and close our profile. So select a 3-point arc, select this. Let's first make this normal and then add a tangency. So here let's see what is unconstrained. Let's press Ctrl Z. Okay, now let's select this and this and made it equal. And now here is a coincidence issue, so select this and this and add a coincidence. So our sketch is fully constrained, which we can see. Now we will come out of it and create a pad of 6 mm. So let's switch to the flat lines view and select the sketch and click on the pad and give the thickness 6 mm. Say OK, and now we will go to the isometric view. Now we wanted to create this profile, and for this we require a datum plane. So we will on our origin plane, and here we see the dimension 80. So we will create a datum plane at a distance of 40 mm with respect to the YZ plane. So select the plane and click on the datum plane and in a Z directions give the 40 mm and say OK. Now let's off the origin plane and rebuild our datum plane. And now we will select our datum plane and click on the sketch. And now here we will create a slot profile on the axis. And now instead of this axis we will give the dimension 51, and let's check if it is on the axis it is 51, then OK. So I will project this edge and let's say smart dimension. So it is coming 50 mm, so it is not on the axis. So we will edit our sketch and delete this slot, and here we will create a same slot but not on the axis, and let's make this and this horizontal. And now from the bottom let's give the 51 mm, and slot center to center distance is of 16. So let's select this center point and this and give the 16. So let's close this report view. And now and if we see here, so this is the tangent to the edge, so this axis is here, so we will provide the tangency, and this radius is of R6, so we will select it and let's hide this report view. Sometimes this report view is very annoying, so you can drag it something at the bottom. Now close it. Now here we will off the datum plane, select the sketch and click on the pad, and we will select up to face, and we will select this face and say OK. Now if we see this front view, so we can see that this is the mirror on the other side, so we will select the pad and click on the mirror, say mirror, and here we will select our reference, which is a YZ plane, and say OK. So you can see that our feature is a mirror on the other side. Now if we see the isometric view, we can see these two holes, and now we will select this face and click on the sketch. And now let's press 0 for isometric view. To create this hole, we will project this to arc, click on the project geometry and project it so that we get a center points. And now let's create a hole. So if you see the side view, so this is the two hole of 6.3. so I will select a circle and create two circle, and select a smart dimension, give it a 6.3 and select this and this and make it equal. Now close it. Now select the sketch, click on the cut and say it true all, say OK. Now we will create these 4 counter bore holes whose position we can see here in a top view. So I will select this top face and click on the sketch, press 0 and set the top view. And now here first I will create a rectangle and make it construction. And now here we will provide the position so that we can project this horizontal and vertical line, and from the edge it is of a 12 mm, give the 12 mm, and from this edge it is of a 10 mm, and from the center it is a 14 14 28. So I will provide this 28, and now provide this which is of 25. So here what I have did, I have first created a position of my holes. Now I will create a 4 circle at 4 points, and let's see the counter bore's detail. So counter bore, we can see that dia 8 is through, and this is a diameter 14 with a 2 mm depth. So here we will create a 4 circle of diameter 8. So we will select the circle tool, create 4 circle, and select the smart dimension and give it 8 mm. Now we will select all 4 and made it equal, and now here we can see that center is offset, so make it a coincidence. So our sketch is fully constrained. Now we will close it, and now we will create this counter bore with a hole wizard, and now here our drill is of 8 mm. So here I will provide the 8 mm, and this will be the through hole, we can say, and in a hole cut type we will select a counter bore. So our counter bore is of 14, and depth is of 2 mm. So you can see that a counter bore hole is created. Set OK, and now if you see the back side which is not visible in isometric, so we will refer the orthographic view. So here in a section view we can see the cut. So we will select the backside face and click on the sketch, and we will project this radius, press 0 for isometric, and rotate our model. And now here we will create a circle and select a smart dimension and provide it 57.19, and this is of a 12 mm depth. Say close, select the sketch, click on the cut, and provide the 12 mm. Now there is a one more cut, so we will select the face and click on the sketch, select the circle and create a circle, and this is about 50.82. Click on close, and this is, we will subtract it 28 minus 12. So we will select the sketch, click on the cut. So here I will give the 28 minus 12 directly, so that it will automatically calculate it, and say OK. Now press 0. Now let's see the minor details. So here our model is completed, and you can see that we have successfully modeled our part from the scratch by reading the orthographic view, and our model is matching with the isometric view. Now we can give the colors. So if select the body and go to the appearances, and from here click on the custom appearances and select this, and let's select the approximate color and say OK, say close. Now we wanted to give the separate color to this face, so select the face and switch to the part workbench, and in a part workbench you will see one options. Let's move it. So here you will see the option of color per face, select it. So here you will see that face is selected, and now click on the custom appearances, select the face, custom appearances, and instead of a green I will provide the white color and say close. So you can see that our FreeCAD model is an exact replica of our reference drawing isometric view. So this show the capability and power of a FreeCAD, that it is a same capable as other CAD software available in the market. So this is all about this tutorial. Thank you for watching, and thank you for your valuable time.